In this video, we're going to learn about MeshCAM, with a specific focus on an introduction to MeshCAM for first-time users and your 3018 first project. We will cover how to download and install MeshCAM, where to find your first project, how to import an STL, create your first tool in the tool library, create a roughing toolpath, then create a finishing toolpath, and finally export your G-code for milling. And then we'll finish it up with a quick time lapse of that G-code running. To download MeshCAM, let's start off by going to grzsoftware.com. Scroll down and select the blue Download Now button. You will be prompted here to enter your name and email to get the MeshCAM demo for 15 days. Don't worry, this is totally free and you don't have to enter any credit card information for this trial. Once you've entered your information, click Get MeshCAM. This will fire off an email to your inbox that will have a download link for MeshCAM and your registration code. Please copy your registration code and select the download link. You will be brought to the download webpage for MeshCAM. Here, we're going to download MeshCAM V8 for either Mac or PC. Since I'm on a PC, I'm going to click the PC version. Download the setup file, and once it's finished, start the installation. Next, we'll accept the end user license agreement and install the prerequisite software. When you are prompted with a Finish button, select Finish. You will now be taken to the tutorial section of the MeshCAM website. But we're going to close out of this because we're going to focus on a tutorial that is applied directly to your first time using MeshCAM and using it with a 3018 CNC mill. To start MeshCAM, hit the Start button on your keyboard and search for MeshCAM, and then start MeshCAM V8. You will be prompted to enter your name and registration code that is found within the email that was sent to you that we copied earlier. Enter this information and select OK. You will then be prompted to try out either MeshCAM Standard or MeshCAM Pro. I'm going to be clicking MeshCAM Pro because I want to show off some of the extra features that truly make this software special. Finally, select OK to the notice that shows we have 15 days remaining in our trial. Maximize the window, and now let's get comfortable with the controls. Left-clicking and dragging will orbit around the origin, where right-clicking and dragging will pan. The next thing we're going to want to do is to set up a couple preferences. Now, the 3018 machine I'm using likes to use millimeter units. So we're going to go up to Edit, Preferences. I'm going to switch my default units from inches to millimeters, and this will help me across the board. All right, now that we have that selected, it is time to figure out what we want to do for our first project. So what I'd like to do is do a little coin that's kind of a lion head on a coin. Now, you can select any 3D object, but I would recommend for your first time having it be a smaller project, maybe 3 or 4 centimeters by 3 or 4 centimeters by less than an inch tall, and then also have it be flat on one side. So let's look at how we're going to load that STL that we've downloaded. I would recommend in the description there is a link for this lion head that I'm using, and feel free to use that for your first project, but anything similar should work. So we're going to go up here and hit load, and then I'm going to go to my downloads and I'm going to select that STL file, and we can see here it's that nice lion head, and I'm going to hit open. It's saying that there's quite a few triangles and that can lead to slow interface performance, but that's okay for this, so I'm just going to select OK. And now we can see here that this is the lion head that I would like to carve out of my wood. Now, it's important to note that we're only going to be able to carve uh, uh, any features that are not overhangs. So you can see his chin here. This will actually be flat because we do not have another axis to come in and mill that out. So we're just going to be milling this, but know that any overhangs are actually going to be flat. So we can see here that we want to machine from the top down. So top is selected. The units are going to be in millimeters. And then the geometry size looks good here, and we can hit OK. Now that we have this to machine, it's important to note that it is a little too tall. So this from here to here is going to be too tall for our piece of wood. So the next thing we really have to think about is your stock size, which is the thing you're going to be doing this subtractive manufacturing with. So I'm going to be using a piece of poplar, and that piece of poplar is about a little over half an inch. So in order to do that, we're going to hit this edit, rotate scale, and we're going to scale geometry. And then in the z-axis here, I'm going to uncheck uniform. In the z-axis, we just want to flatten this down a little bit. So in order to do that here, it looks like we're at 23 millimeters. I want to pull this back down to about 12. So I'll put 0.5 here, and that's going to cut this depth in half. So then I can hit OK. And we can see that that has flattened it, right? And that's going to be a lot easier for us to mill because it's more of a flat surface, and our tool depth isn't going to be too extreme there. So I'm really liking where this is going here. And I have now completed importing an STL and scaling it to the correct dimensions. Now I have measured my wood, and it's about 12.7 millimeters thick. So it's time to set up our stock now. And so now that the program knows what we want to cut, we have to tell it what we want to cut it out of. So under stock, we'll hit edit. And we can see here that it is just defining the stock from the origin, or the 0 point here, which is what we want. But our Z is a little bit too short. So I'm going to type in 12.7 here. And that should be good. And we can see here it is now added that little tiny bit of extra geometry there, because that is how thick the wood is that I want to work with. Perfect. Okay, so I'm going to be okay with where this point is, because in the machine later, and we'll talk about that, I'll move the machine to more towards the middle of the working area and set that as my 0 so that I know exactly where this is going to cut. The next thing we want to do is add a tool. So to add a tool, we're going to go up to Job Setup and List Tools. Now I'm going to show on screen right here the kind of workhorse bit that I like to use with the SaneSmart 3018. It can be a number of different bits to do this correctly, but a great starter bit is a 2 Flute 2 millimeter diameter 1/8 inch diameter shaft end mill. And I'll put the link right here. All the links for all of these parts will be in the description. So I would recommend purchasing a bit like this. It's a very common bit before you move forward. The V bits that come with the SaneSmart are going to be just a little too detail oriented for what we want to do. So again, we'll use this bit. Now we have to create this tool in the tool list. So I'm going to delete this tool here, and I'm going to add a tool. And now we can see here we have all sorts of interesting acronyms here, but this is actually pretty easy. So in the description, I'm going to type in 2 millimeter end mill. Tool number 1 is fine. The overall length, this is where it's handy to have a pair of calipers, which I'll also link in the description. The overall length of the tool is 38 millimeters, or 38.5. So we'll do 38.5. The shaft diameter is the diameter of the tool, but not the diameter of the cutting area. So this is going to be 1/8 of an inch, which in millimeters is 3.17. Then we have our flute diameter. Now the flute diameter is the actual working diameter of the tool, and in this case it is 2 millimeters. Then we have our flute length, and the flute length is the working area, basically where you see the saw of the bit go up to, and in this case it's right around at the 12 millimeter mark. And then the corner radius for this one, it's a flat end mill, which means it does not have a corner radius, so it's going to be 0. Number of flutes is 2. Okay, so there's our tool, and we hit done. So now we have our tool set up, we have our stock set up, we have our model set up, and it's time to create our roughing toolpath. So in order to do that, we'll go up to toolpaths, and in this case, we want to do both a roughing and a unified finishing. Now a roughing is going to take most of the material away, and then a finishing is going to come back and give us all these nice details that we want. So under toolpaths, I'm going to click roughing, select tool, this end mill, hit done. So now we have that. And I'm going to go with a pretty slow feed rate, and this is in millimeters here, and I'm going to go with 600, which is a good starting rate for your mill, and especially the 3018. And then our step down, 0.4 works just fine. We want to do 3D roughing, and we want to hit OK. Now, let's take a look at what this just did. So I'm going to hit Calculate Toolpaths. It's going to take a moment to calculate the toolpath. And what this is doing is what makes MeshCAM truly special. Normally, you have to really go in there and define every single thing you want the tool to do. And it's not really like a slicer with 3D printing where it's just click and go. Well, MeshCAM is click and go for the most part. But then it also is flexible. So if it's not acting exactly how you want it, you can come back through and change any parameters that you want to. So it's kind of that perfect mark between going advanced but keeping it simple. And this may not be the product you want to use for really industrial, making thousands and thousands of things, right, in a production setting, but for someone who doesn't want to learn about the nitty-gritty of milling and milling settings and all of that, this is going to be absolutely perfect. So if you're a hobbyist or you do any kind of artwork, this is wonderful. So here we can see show geometry, show rapids, and this is the setup. Now, this button right here is one of the pro features, and it actually shows you what the tool is actually going to do, and it simulates the material and what's being pulled away from that material. So what I'm going to do here is hit Simulate Toolpath. There we go, and then we are going to uncheck this rough operation, and this is one of the pro features. So without the pro software license, you won't be able to see this. And all you will be able to see is the lines in which the toolpath is going to go, which is fine, but I really like to see this, approximation of what the tool is actually going to do. So what we can see that it's doing here is it's going to take away almost all the material, and that's good because I actually want to leave a little bit on the edge here to cut out with a saw later. I want my CNC really to do the most of the detail work here. So we can see this is a roughing pass, and it's cut away most of the material, but it hasn't created a very detailed finishing look. So that's all fine and good. I'm going to hit done. And now we want to do the finishing toolpath. So I'm going to click Unified Finishing, select Tool, and we are going to select the same 2 millimeter here and hit done, just like that. The feed rate, I'm going to drop down to 800. because we've moved most of that wood away, it's okay to increase this just a bit. And all of this looks good. And I'm going to hit OK. And now let's calculate our toolpaths again. And it's going to go through and it's going to do the rough, and then it's going to do the finish, and it will show us the approximate look of what our piece is going to look like. All right, so we can see here that we have the roughing operation, then we have the finishing operation. It looks like this big green blob. And this is what you are going to get. If we turn these off, you can see that this is the tool path here. And this is what you're going to get in the standard version. We can turn off the roughing so we can just see what the finishing is going to do. And it's going to come in here and it's automatically detected all this geometry, and it's going to cut in and really give us a nice final detailed finish here. And that's a little different than the roughing operation, which we can see is mostly material removal. Now, this is what you're going to see for the standard version of MeshCAM, but with the Pro version, which is what I want to do, I'm going to hit Simulate Toolpath. And this is actually, again, simulating what the material is going to look like once these operations have happened to it. All right, so now I'm going to turn off toolpaths here, and we can see that this is going to be our finished product. Now, you might be wondering, why are there all these little extra steps and lines and things, right? That's because we're using a pretty standard 2mm Flute flat end mill, and the flat end mill is where we're getting a lot of the stepping here. Now, for your first project, I think this is absolutely serviceable, and this looks fantastic as a piece, and it's something that I think is a good first run. If your machine can make this, then we can step it up later with some fancier end mills, like a ball end mill or something like that, that can really take this to a nice finished look. So now that we have this all set up and it looks good, we're going to select both of these and select Save G-Code. Now this is going to pop up and it's going to ask us a couple questions. And the main one here is, what type of machine are you going to use? So if we're going to be using the 3018 Prover or 3018 Pro, that operates on Gerbil firmware, or GRBL. And that means it's going to send special commands to the machine so that it can understand things like home positioning and limiting and speeds and feeds and things like that. I am using a Mach 3 control board, which is just a little different. So I'm going to select this. But if you're using the Mach 3, do Mach 3mm. If you are going to be using the Prover version, then I would do Gerbil millimeter. So I'm going to do this Mach 3mm right there. And then I'm just going to save that in my documents here, and we will call it Lion Coin, like that, and hit save. So now it's saving that, and if I open up my documents here, go down to Lion Coin, and I want to open with Visual Studio Code, and we can see here is the G-code. And it has all the M commands for Mach 3. It tells me my spindle speed, how to change the tool, and then this is the G-code it spits out. Very similar to slicing with a 3D printer. Now, we did all of this in a very short amount of time. This style of operation using a different tool would have taken quite a bit longer and may have been more expensive. Now let's say, okay, I actually want to change something in here. I want to go in and fix, something. I need to add a bit more speed, or I want my step down to be different. That's extremely easy to do. You can just go up to toolpaths, roughing, and we can change these and then redo them. and it's right there. So not only do you have the ease of use to create your first project here, but you also have the ability to go in and change some more advanced settings. So now that we have imported our STL, created our tool, did our roughing operation and inspected it to make sure it's what we want, we've also created our finishing operation to smooth everything out, and we've exported that G-code. So the next thing to do is plug it into the machine, set up our material, and hit mill. They're ready to be cut out with a saw.